In the name of Allah, the Compassionate and the Merciful. Hello guys. My name is Salar Delavar Qashqai, and in this video we're going to have an example about the modeling of non-prismatic elements with multi-prismatic elements, and then with an optimization problem we want to find the optimum web height of this non-prismatic eye section. So let's see, in this column we have 50 nodes and 150 degree of freedom. So based on these 50 nodes we have 49 discrete elements. So this column divided to the 49 elements, and with these relations between esters and esters for steel fibers, we want to model this pushover analysis, and with definition of demand moment we want to find the best optimum bottom web height of this column, and then with the linear relations between this web height of this column we want to simulate each height of this increment height of these elements. So you see that, guys? So we have 49 elements for this column, and then in each height of this column we have different web height of this column. So, and you see that, guys, if we run this optimization problem with the pushover analysis, you see that with the 9 iterations we got the optimum value for this bottom web height of this column. So let's back to the OPENSEES file. You see that I defined functions for calculating the maximum absolute value for reading and calculating the maximum absolute value based on outputted data, and then defining the pushover analysis function. You see that, guys? In here I defined 50 nodes and 49 elements properties. You see that, guys? So each web height is going to be calculated with these linear relations, and I defined this value as a definition of this analysis at the beginning. You see, so the top column web height must be half of this web height. So I mean this value must be 50% of this value. And you see that, guys, I defined fiber properties and also the analysis properties, and in here I defined the non-prismatic eye section web height optimization. So our column is 3000 millimeters. So in each increment, if you divide this value to this value, you can see that 60,000 divided to the 50. So in each 60 millimeter we have one element, and you see that, guys, I defined weight of this at the top of this column, and then definition of the initial guess of this web height, and then tolerance, finite difference value for convergence evaluation, and then residuals and other parameters, definition of maximum pushover analysis. So in each analysis, the incremental displacement goes to the 10 millimeters based on this definition, and then we're going to have a target base moment as a this value, and then trying to read the output. So you can change your analysis as a target of displacement, but in this analysis I use the target of base moment, and you can change it with your own values. And in here we run the optimization code, running the pushover analysis, and then finding our target function, and then defining the x minimum and x maximum based on Newton-raphson Method, and then finding the finite different derivatives of f, and then calculating the dx as a residuals, and if it is converged, so we get the solutions. And then you see that, guys, after 10 minutes with the 9 iterations we get this solution. So the optimum web section height is equals to 81, and if we want to plot each height of this element height as a non-prismatic sections, you see that, guys, in each element with the number and the column length of this section, you see that it has different height. At the beginning we have this value as a defined it as a this value, and then at the end of this column we have this value as a 50% of the this value. So you see that, guys, we can model the non-prismatic eye sections with the finite prismatic sections, and based on this process we can have a optimization problem to finding the best section web height for each of these non-prismatic eye sections. So thanks, guys. This video's purpose is for just as an educational purpose. Please have a comment and tell me about this kind of modeling. Bye.